Welcome everybody to another grade 11 mathematics video. So today we'll be looking at probability. Alright, so the probability of an event can be defined as follows. Probability of an event is equal to the number of outcomes in the event divided by number of outcomes in the sample space. Right. Probability of E is equal to N of E over N of S. That's how it is abbreviated. You can abbreviate it like this. Now, here's what you should know before dealing with any question, any equations, okay? Because on these diagrams that I have here, this is where some of the general rules of probability come from. As you can see, these are Venn diagrams, right? And these will show you where all the equations of probability are derived from. Now, first of all, we have intersection. The intersection is where this and this, where B and A meet or are equal to each other. So this part over here, that's the intersection of A and B, and it is called A and B. That's the intersection. So in terms of probability, you would say this is the probability of A and B. Moving on, we have a union. So a union is everything in A, everything in B. Okay, everything in A, everything in B, as you can see by the shade I have here. So this is called A or B. The union is called A or B. So make sure you know that. Then next up we have mutually exclusive. So mutually exclusive means there are no intersections. There are no intersections. That means the two events cannot happen simultaneously, like so in the diagram. As you can see here, we have event A on its own and event B on its own. There is no intersection, which means they cannot happen. Event A and B cannot happen simultaneously. Let's move on to the next slide. Moving on, we have exhaustive. So exhaustive means the union of two events is equal to sample space. So when we're talking about exhaustive, we're saying that two events are equal to the sample space. So we all know probability is on a scale of 0 to 1. 0 is the minimum and 1 is the maximum. So here what I'm saying is A and B is equal to the sample space. That means A and B is equal to what? 1. Now moving on. Now we will discuss the rules of probability, the equations that you're gonna use to solve equations, to solve problems. Okay, so first of all, we got the general rule. This is the most basic rule in probability. You have to know this one. You have to make sure that you don't forget this one. I mean, it might be there on the answer sheet, but I feel like you should know it by head. You should just know it. So listen. So it says here, P of A or B is equal to P of A plus P of B minus P of A and B. Now, let's see if we can remember. What was P of A or B? The union, right? And then P of A and B, intersection. Moving on. So we have an example here. Two events A and B are such that P of A is equal to 0.3. That means we have this one. We have P of A. P of B is equal to 0.4. We have that. And P of A and B is equal to 0.1, and we have that. That means we're looking for this one. So in our equation, it would be as follows. P of A or B is equal to 0.3 plus 0.4 minus 0.1. And if you press that on your calculator, it should give you 0.6. All right, moving on. Mutually exclusive events. Mutually exclusive events, like I said, they have no intersection, which means they cannot occur at the same time. They cannot happen simultaneously. So P of A and B should be equal to 0 because they cannot happen simultaneously. So their probability is equal to 0. Then exhaustive events are two events that are equal to the sample space. So P of A or B is equal to 1. And remember what I said, P of A or B is a union, correct? Now moving on, we have complementary events. So for complementary events, we have this. It's a combination of the intersection and the union. So P of A and B is equal to 0 and P of A or B is equal to 1. When you combine it with the general formula, the general yes, the general rule, you have P of A plus P of B is equal to 1. How? Let me show you real quick. So we have P of A of B is equal to P of A plus P of B minus P of A and B, right? So P of A of B, it's a union, right? So it's 1. P of A plus P of B. Then P of A and B is 0, right? So there's no need of writing 0 because minus 0 is still minus 0. So that's where we derive this over there. Then we have independent events. Now, independent events are represented by this formula here. So P of A and B is equal to P of A times P of B. What this means is for an event or events to be independent, P of A and B must be equal to P of A times B. For example, P of A and B must be 0.6 and P of A times P of B. The value for P of A multiplied by the value of P of B must give you 0.6. So both sides must be 0.6 for them to be independent. But if, for example, here it's 0.6 and the result of P of A times P of B is maybe 0.4, then the events are not independent. Yes, are not independent. They are dependent. That's what you should know. So that's it for this video, guys. Next video, I'll be explaining the Venn diagrams. So see you on the next one. Peace.